Okay, so everybody, hey, I'm Jan, and today I'm going to be presenting Project Livon, a way to automate Maker's risk assessment and also how to expand it across the whole DeFi ecosystem. And I work as a data scientist at Analitica. We are an R&D company that specializes in DeFi economic risk intelligence. And the aim of this project is to assess the individual borrower risk from the economic standpoint. To go through the topics, I'm going to begin with introducing credit scoring and also contextualizing it in terms of both TradFi and also how to map it to DeFi and some differences there. Then I'm going to go a bit more specific when it comes to economic risk engine and why that matters. And I will continue with Project Livon, which is the product that we launched. And in the end, I'm going to also give a short introduction to the product and how you can use it yourself. And finally, I will also present some ways that the product can be improved and also integrated into various protocols and how it can be implemented. So to begin with, traditionally in TradFi, credit scoring has been about assessing the capacity of borrowers to repay their debt, and that meant different way to evaluate this, like the FICO score in the US, and there are different systems in the EU region. And on the other hand, we have DeFi, which through the transparent data layer, we can do a similar thing. But the difference is that in TradFi, we have legally enforceable rules, and in DeFi, we don't have that. We comply by the code is law principle most of the time, and that's why we need different systems. And in this case, we've seen a proliferation of highly over-collateralized lending protocols, such as Maker, Compound, Aave. And the way they operate is that they have liquidation systems in place, and in case of under-collateralized positions, or like when vaults or different kinds of entities go beyond a certain threshold, the liquidation ratio, then they are to be liquidated and the collateral being sold. And that means that we need a different system in place that we have in TradFi. And in this case, this means the importance of economic risk and management in DeFi, which means that we are trying to assess, given a certain, let's say, price drop, how can the system respond to that, given also the current state and also the historical behavior of different users interacting with that system. That means the importance of both assessing the user risk and also the portfolio risk. And we can assess the historical behavior, the behavioral patterns on the user level, and then we can bring a bottom-up approach to the portfolio risk. And we've seen two different major metrics on both on the collateral level and also on the portfolio level. First one is value at risk, which comes from TradFi, and something that we've developed in our team is capital at risk, which is, in this case, a maker-specific metric. We can see it on the slide. It has this nice view of riskiness over time, and if we see a spike in that metric, that can inform also our ways of proposing the risk parameters of the system. So it's a very nice way to use advanced analytics to bring up signals of how the systems operate. In general, again, because of Ethereum's transparency of the transactions, we have this really good insight into behavioral patterns, and there's many ways to use computational techniques to derive insights from that. One way to split this into simulation modeling, which is basic methodology that we use in a lot of our use cases, and machine learning, which we are using also in the Project Livon. And we applied it to the problem of decentralized credit scoring. Decentralized component here means that it's applied to decentralized protocols. And there are two main reasons why it matters. The first one is the ecosystem robustness, and that means that by better assessing the risk, we can also then understand different risk vectors and potentially also or necessarily also mitigate against those risks. And then on the other hand, we also have the improved capital efficiency, which means that we better understand the riskiness of the protocol, and through that we can, if the protocol is assessed as, let's say, safe, then we can decrease the necessary over-collateralization, and through that improve the capital efficiency. And ideally, let's say, also move in the direction of under-collateralized lending, but that we haven't really seen successful use cases in that area. And in the end, this also brings a very important topic when it comes to decentralized identifiers, and when it comes to just tracking different behavior on chain. And at the same time, it can bring this kind of like a really nice financial reputation primitive into the equation. To get even more specific about the project Liwon, it's been launched into public beta, and I'm gonna also share the website at the end. But in general, it's an ML-based framework that uses liquidations as a proxy for default. So there is no technically default in DeFi. That's why we have this liquidations as a proxy, and that makes it a binary classification problem. That means ideal for machine learning modeling. And additionally, what we're doing under the hood is that we estimate the probability of default given the worst historical price drops. So we get the training data of all the history of Maker, and then we take the worst price drops, and we can also expand that, make it a bit worse or make it a bit better, and then we can see which vaults would be liquidated given the data, the fitting of the model. And at the same time, we can go both from the user level, and we can bring it up to the portfolio risk monitoring, which we can see on the slide. The chart shows the proportion of debt that is graded with a certain credit grade. In this case, we go from credit grade 1, which is very high risk, to credit grade 10, which is very low risk. And then we can see the proportion changing over time, and that, again, tells us about the risk profile of the portfolio. Without going too much into detail, this is a simplified representation of the system diagram that we're using for the Liwon risk engine, which is the logic, the system behind the computed credit grades. We move from the Maker-specific data, which is on-chain data, and then we build signals or features on top of that. We build a vault liquidation ML model, and through transformation and aggregation, we get the wallet level credit score, because, of course, like one wallet can have multiple vaults. And then on top of that ML model, we also apply certain heuristics based on our just domain knowledge from years of experience in DeFi, such as credit mix, which is the riskiness of the underlying collateral, and externally held capital, because, of course, let's say, given a certain collateralization ratio or like the protection against a certain price drop, if the wallet has a lot of capital elsewhere, they can use that to repay their debt or just increase their collateral, and through that improve their collateralization ratio. And when we bring all this together, we get this credit grade, which is the final output of the methodology, and also something that you can see in the product. Then we move on to the product itself. This is the landing page of the Maker credit grade. We also see basically a more DeFi-wide landing page, but that's basically also that we are developing for also Compound and Aave. But this one just presents Maker-specific data when it comes to how to use the product, and one way is to interact just by adding the wallet into the entry, or given that there's many wallets and you need to look on chain or like on some dashboards to get the right wallets, you can also have sample wallets per each of the credit grade, and you can click through that and get the reasoning behind the credit grade as well. And that's one of the key components that I'm going to go deeper into. This is an example of one sample wallet, and we can see that it has a credit grade of 9, which is very low risk. And the important thing as well here is that we see a portfolio distribution comparing it to other wallets. So here we have a wallet count on the y-axis and the credit grades on the x-axis. Then we also have certain basic stats around the wallet, in the maker system, such as number of wallets, collateral, and depth. And we can, of course, also expand that to get even a more holistic view of the wallet inside of a system. And then we come to the most crucial component of all this methodology. Because one thing is, okay, you get the methodology and you get a grade, and then it also has to do with explaining why that grade is actually there and the reasoning behind it, right? So we have, again, the ML model, which is the baseline score in this case, we can see. And then we have other heuristics on top of that, such as the quantization buffer, which is basically is computed by dividing quantization ratio over liquidation ratio. Then we have the two heuristics that I mentioned, credit mix and external capital. And then we also have certain other interesting components, such as protection service, which means that whether the wallet is using third-party services for the automation of the managed position with DeFi Saver or Oasis or these kind of services. And this is very important because what we want to do is, okay, we have the on-chain data, we have the modeling, but then we also need this core component of the explanation to increase the transparency of the systems. I'm not going to go too much into this, but we also have this analysis section, which goes into different components of the methodology. And if you have some questions, I'm definitely happy to answer them later. But here, for example, we have the grade analysis. That's, again, the target value, the final value that we compute. And we see the split across different categorical estimations of the, let's say, high risk, low risk, and so on. We see on the left, the top left. Then we see the wallet count distribution, similar as we did in the product itself. And then we see as well a temporal dynamic of both relative depth and also relative wallet count over time. And that, again, we can see a nice portfolio risk profile through that. Then we have the factor analysis, which is just, again, the signals around it. This is not the factor analysis in the typical statistical analysis. This is something that just means different signals in the system or features in machine learning lingo. And we can see based on the number of wallets, the quantization ratio buffer that I mentioned. Then we have also the tenure, because intuitively, the longer somebody uses the maker system, because we are taking the time of the first open vault by that wallet, the more experience the wallet owner has, the less likely it is to be liquidated. And then we can derive some kind of insights that give us signals to the machine learning model. Another one is how recent was the last activity, which can be also relevant, and also, interestingly, how we can also estimate that the user uses some kind of bot. And through that, we are checking how equally distributed, let's say, are the events across all the time zones. Because we can see that if the wallet interacts with the vault on a continuous basis throughout all the time zones, that's likely to be predictable of being a bot. Not necessarily, but still, it can be informative when it comes to the capacity of the borrower to protect their position. And something that to mention here as well is that if the wallet has a very high quantization ratio, then the behavioral component is not that important because it's protected against the price shocks. But if it's a low quantization ratio or a low quantization buffer, then the behavioral component matters a lot, and then it really matters to what extent how responsive is the wallet owner. Another component is the heuristic that I mentioned before, the external capital that we bring into the model, and we split that into two parts. One is something that we call passive capital. That means capital or assets that just lie in the wallet themselves, and they are not used in any other protocol other than Maker. And then on the other hand, we have active capital, which is capital that is used in other protocols. And then on top of that, we have certain adjustments of this capital when it comes to slippage or just general domain knowledge when it comes to the haircuts, because we know that certain protocols are just more riskier than other and so on. But because obviously, a shitcoin, like a huge amount of shitcoin, cannot be used that usefully in the to repay their debt because of the low slippage, usually. And here we also see the chart on the bottom left, which compares the distribution of different wallets, and what it looks at is the external capital of the wallet and also the debt, and that's what really matters when it comes to debt repayment or increasing the collateral, because what we're interested in is the relative relationship there, and through that relative relationship we can see how much capital power basically that external capital has for the given position, right? Because, for example, if somebody has millions in the wallet, like basically external capital, but it has billions in the position, that's not as relatively important for improving the collateral ratio. We also dove deeper into segmentation analysis. That's under the hood is just some clustering analysis, going to the behavioral patterns of the users and splitting them into different categories. There are categories such as whale, high utilization ratio, whether the wallet is automated, whether it was liquidated before. There's just a lot of these kind of categories that are interested to both estimate on the current state of the system and also to look at through time. Finally, we have the idea of how to move forward, right? Because the 11 grade is something that is applied at the moment just to Maker, but this can be expanded to other protocols as well. And the most interesting use case is, of course, extension into cross-collateral protocols, such as Aave, Compound again, or Spark. And through this, we can have a more DeFi-wide score. When it comes to implementation, there are many ways to go about this. One of the ways is whitelisting. And whitelisting basically means that if the wallets have a good creditworthiness, then we can give them better or basically the access to certain services. And then on the other hand, we also have preferential treatment, which means, again, good creditworthiness. That means that they have lower liquidation ratios or lower stability fees, or let's say slower auction times, depending on the specific system or basically the protocol that they're using. And finally, we also have a more long-term vision when it comes to integrating that into a more decentralized autonomous service through different frameworks that are just popping up more and more and getting more and more mature. One of them is Autonomous, which provides exactly that, but that means that the credit grade can be integrated into protocols through various ways, right? There's also Ocean Protocol, which enables just privacy-preserving ML models. Then we have also let's say Bacalhau with the compute over data. So there's a lot of this kind of infrastructure that is being developed that we can integrate this into, right? Like the methodology itself is one thing, productionizing is another, and then the integration and really building a use case is something separate, but extremely important to work on to make it useful. Finally, this is the QR code for the app. You're very welcome to scan this and just play around, just inputting different wallets or just playing with the app. And the important thing is also the explanation. And we are very happy to hear any kind of feedback that you have around just how we can improve this, how it can be maybe integrated into some of your services. And yeah, just very happy to hear your feedback. Thank you. Questions?
Hi. How fast does my credit score update? So if I see, okay, I want to get this preferential treatment, my credit score is too low, I maybe fix some things, and then do I have to wait for a week to you guys to scan the blockchain again to reevaluate that?
So at the moment, we update it on a daily basis, but obviously this can be, improved, and just depends, if you offer it as an Oracle service, that can be pretty much instantaneous, semi-instantaneous, right? So there's many ways to go about this. Like one thing is building it, but then it's like really optimizing for a specific use case. Because you also want to kind of think about all the ways that somebody can game the system, right? And that's something that you want to really integrate into the solution itself to mitigate against those risks.
Thanks for the presentation. My question will be, how do you assess the quality of your risk engine?
So what we do is that, given our methodology, then we also have certain metrics, right? For example, something that I didn't mention is that one of the biggest problems that, let's say, this kind of modeling has is that, or this kind of problem is that you have a huge class imbalance, which means that you have way more wallets that are not liquidated than liquidated, right? And then you have this class imbalance, so it means it really matters which metric you're using. Accuracy doesn't work, then you need, F1 score, precision recall, or ROC AUC, and like that final score is how you basically evaluate the model, right? But at the same time, it's different companies can model this in different ways, so it's very difficult to compare these apples to apples. So there would need to be some kind of framework that all the solutions use the same methodology, and then you can compare it apples to apples. But I can give you the score, but that always is context dependent, right? The way you model the problem determines also like how good how easy it is, or like how difficult it is for you to get a certain grade, like a certain performance score, right?
Yeah, I see that like the huge variety of models like is a problem, but my question was more rather around you get a certain number for a wallet, and how do you understand if this number is reliable? Do you have some like back test of your system or something like that?
Yeah, I mean, technically, what we're doing is in the ML methodology, what we're doing is a train test split, and then we do k-fold cross-validation, and through that we get the final grade, right? Like the final probability, and through that we go forward, right? But that's basically like that probability. This is something that we are getting the model performance from, right? Hopefully, I answered your question.
Thanks. But I mean, the standard advice for security is that, if you open a vault at Maker in one address, then you use another address to interact with Curve and another address to interact with Compound, because each smart contract is, well, we're still experimenting, so they're all black boxes. So rather than blow up, have everything in one place, you tend to, well, many people have 50, 60, 100 addresses. And so are you analyzing the linkages between all of them? Because otherwise you're just seeing one place and, oh, they're doing Maker here, but you don't know what they're doing over here. So it doesn't really give you a picture of a user's. It doesn't really analyze anything. It just takes one snapshot of a part of the elephant, if you see what I mean.
Yeah, I definitely, it's a very good point. It's a very good point. And the way to do this is, once you build the solution, you want to incentivize people that they bring more and more wallets into the picture, right? That the more wallets they have, or let's say, they can build a certain portfolio of wallets, and that basically creates the final grade, right? Like at the moment, this is just on the wallet level, but just like we are combining different wallets together, right, into one wallet, you can also combine different wallets together into one bundle of wallets, which is the actual user, right? So it just depends about creating the right incentive structure for people to share their wallets, right? And that, ideally, to basically prevent kind of doxing, like you also want to make this privacy preserving, right? So, and that's kind of like a final solution that would be more aligned with also like what you said, right?
But just to follow up, at the moment, you can't present a grade for the bundle, if I put it that way, or can you? Because I noticed, for example, MetaMask Portfolio Manager is sort of bundling and linking many addresses now, and are you doing that, or you still haven't got a solution to bundle things together and say, oh, this person is using this and this and this and this here and this here? You can't do that. You can or you can't?
Yeah, so at the moment, we don't have that solution in place. So what we can do is, what we have at the moment, our solution is that for all of the users that have an open vaulted Maker, we create the credit grade, right? And then if somebody has multiple wallets within the Maker system, then we can bring that together into one. That's something that is already been brought in place, right? But then a separate solution is that you go into all the Ethereum wallets, right? But then the problem there is that it's much more difficult to detect a real signal. There's just a lot of noise and not much signal, you know. And then also it's not that instantaneous. You cannot, you know, you cannot update the credit grade for everyone, for all the Ethereum wallets on a daily basis, right? That's something that is definitely not scalable. So it really matters that you're able to narrow down on a specific problem, like on a specific set of wallets, and then go from there, right?
Yeah, I have another question. You're using machine learning, right? Do you anything in order to make crafting adversary samples harder or maybe impossible? So because all your train data is open, right? I could train my own model using like a similar architecture and then use that to come up with an specially crafted input that would, for example, give me a very high scoring when in reality I'm not really trusted.
I mean, the problem with transparency is also that it's easier to game it, right? So there's obviously this kind of trade-off that you have. Okay, how transparent do you want to be? That's why also like there's a lot of features that you know that are important, you know, but some of them are showing, some of them are shown, and some of them are not like exactly how they're crafted in the background, right? It's just a high-level idea, right? So you know, and often like you want somebody to like if you design the system the right way. It makes sense for them to game it because gaming it means okay, like they increase their external capital, right? It's like okay, like it's good, right? In the end, so it's like so there's a lot of ways okay how we can show the right data to the users, and you increase the resilience of the robustness of the system, and then like they're gaming the system, like their pursuit of their own goals is the pursuit of the goals of the design of the system as well, right? And then there is you know just incentives that are aligned, but like to get like really specific to your question is like we haven't done really like proper like you know like really attacks you know that can be done on the system. Like I think that's really like you know solution down the road.
Okay, so yeah, yeah, there's something you guys should think about, right? If you create scoring, I don't think the incentives are really aligned with the people that are using that. At least it could become very fast that like a center set is aligned, and you still have Oracle access to the system, so it would be probably easy to craft something like that.
Yeah, so in that way, like I think it's a tinkering process, right? So you begin with creating a solution, then you integrate it into you know certain let's say protocol, and that can give you then the data on how you protect against that, right? One thing is okay, we can predict in advance or like think about how they can game the system, and another one is okay, like we have it in production, people are using it, and then you can detect you know like fraud or you know those kind of ways. So I think it's an evolving system, right? Thank you.
No more questions. A big applause.